Stacks only let you work from one end. Queues only let you add at the back and remove from the front. What if you needed both, fast operations on either side at the same time? There's a structure for that, and almost nobody teaches it properly. It's called a deque, short for double-ended queue. It combines what stacks and queues do individually into one flexible structure. Today, we're covering exactly how it works and where it actually gets used in real code. A deque lets you add or remove items from both the front and the back, all in O1 time. Think of a line at a buffet where people can join or leave from either end, not just one. That flexibility is the entire point. If you only ever add and remove from one end, a deque behaves exactly like a stack. Last in, first out from that single side. So technically, a deque can fully replace a stack whenever you need one. If you add items at the back and remove them from the front, that's exactly queue behavior. First in, first out. So a deque can fully replace a queue too. One structure, two completely different behaviors, just depending on how you use it. Here's where a deque earns its own identity instead of just mimicking the others. A browser's history feature that lets you go both forward and backward, a recently used list where you remove old items from one end while adding new ones to the other, and sliding window algorithms, which we'll cover later in this course, all genuinely need access from both ends at once. Under the hood, a deque is usually built using a doubly linked list. Remember the one with pointers going both directions, or a specially resizing array designed to grow from both ends efficiently. That's exactly why doubly linked lists matter beyond just being linked lists with extra pointers. Here's what trips people up. Assuming a deque is just a stack and a queue mashed together without understanding why that matters. The real value isn't that it can do both, it's that it does both efficiently at O1 on either end at the same time. Using an array-based structure that isn't built for double-ended access will quietly turn one of those ends into an ON operation, defeating the entire purpose. A deque allows O1 insertion and removal from both the front and the back. It can behave like a stack, like a queue, or use both ends simultaneously for things like browser history or recently used lists. It's typically built on a doubly linked list or a specially designed resizing array. This is video 11 of the full DevVerseX Data Structures and Algorithms course. Subscribe so every structure keeps stacking together the way it's meant to. Coming up, hash tables explained, how Python dictionaries actually work behind the scenes, and it's one of the most important concepts in this entire course.